if we were to rewind the clock back about 70 million years, you would see dinosaurs roaming the earth. And this is a very nice picture here of a dinosaur enjoying a sunset at the beach. But unfortunately for the dinosaurs, about 65 million years ago, we believe that a huge meteorite struck the Earth and essentially wiped out the dinosaurs. And it probably wiped out a bunch of other species with it. Because you can imagine the shock wave itself would just exterminate tons of species. Then you would have the tsunami of unimaginable size that would just envelop the continents for some period of time. And then you would have all of the soot that would go into the air and maybe make it impossible for most of the plant species to live because it would be blocking out all of the sunlight. And so in an environment like that, we could imagine that an animal like this would be well suited to survive. It's sitting there underground. Maybe it can hibernate in some way so it doesn't need food for long periods of time. Maybe it has its own food stash under there someplace. And so we believe that our ancient ancestors, after this mass extinction event, might have been something like this, kind of a mole-looking rodent animal that was protected from all of this craziness that was happening on the surface because they like to hang out underground and have all their food nearby them, and maybe they could hibernate in some way. So you can imagine once everything settled down, and now we're talking, who knows, hundreds of years, thousands of years, even millions of years, some of this guy's descendants start to poke their head out of the ground. You're like, you know what? There's food in trees, and there's no one else in the trees, and trees are a good place to maybe get away from some of the other predators that have managed to survive this mass extinction event. And some of its ancestors or some of its descendants, I should say, that were good at climbing trees decide, hey, let's try this tree thing out. And so you started to have some selection for the descendants of this rodents that could climb trees well. They were able to find food where their ancestors couldn't. They could find protection in the trees where their ancestors couldn't. And so you could imagine that some subset of this guy's descendants evolved into something that might have looked like this guy. And all the pictures I'm showing you, these are of modern animals, except for, of course, the dinosaur. I'm sure this was kind of photoshopped in some way. This is a modern bush baby, but I show this picture because it could have been what some of these primitive primates look like. Because a bush baby, it kind of climbs trees. It kind of looks like it's starting to get a hand here to start climbing the trees, but it also has rodent-like qualities. But this is, of course, a modern version of it. So this bush baby's ancient ancestor might have been that primitive primate, or that species of primitive primate that was a descendant of rodents that started saying, hey, let's see if we can climb these trees and find some food. And then some of its descendants might have had just the right adaptations, found their own little niche in the right ecosystems, and they would have evolved into monkeys. Once again, this is a modern monkey, but you could imagine some type of primitive monkey. And then some of those primitive monkeys' descendants, they turn into these modern monkeys eventually, but some of them, they grow larger in size, they spend more time outside of trees, they lose their tail, they don't need it as much for balance. Maybe it's actually a bad thing to have because someone else could grab it when you're in a fight or something like that. And they evolve into apes, and in particular the great apes. So one of the great apes involve gorillas and chimpanzees. And the ancestor, or really the great apes, also include humanity. So let me just review back on this timeline just so that we don't get confused. I'll review what we just talked about. So before this mass extinction event, 65 million years ago, you had all these types of species here. Maybe this right up here, maybe this was, actually if I'm talking about species, maybe this was Tyrannosaurus rex, because the dinosaurs involve a whole bunch of, so this might have been T-Rex, and there's a bunch of species that we could list over here. But after that mass extinction event, that was an endpoint for a ton of species, except for maybe this primitive rodent mole-like thing that was maybe a lot of them died in this event, but just enough of them survived because they were underground or just in the right place, or they're in a mountain someplace. Who knows where they were? And some of them were able to evolve into primitive primates. And some of those primitive primates, and this is once again, these are pictures of primitive primates. Some of those primitive, and when I say primitive, these are modern versions of them. So primitive doesn't necessarily mean worse, because obviously these guys were able to find, even in today's world, they have a niche for themselves. They're able to find food and reproduce in ways that don't get in the way of other people, and other people don't get in the way of them. when I talk about primitive primate, I'm just talking about kind of an ancestral primate, maybe something that's not there today, although maybe some of its descendants look very much like it. But anyway, some of those primates evolve into primitive monkeys. Some of those primitive monkeys' descendants become modern monkeys. So this is, I'll call it M monkeys for modern monkeys. And some of them evolve into primitive apes. And apes, their distinctive characteristic is that they're like monkeys, but they don't have tails, and they're larger than most monkeys. And so these primitive apes, some of their descendants are modern gorillas. At some point, they break off. Some of these descendants are a ancestor of both modern chimpanzees and of human beings. And we think, just looking at the DNA evidence, we think that this departure right here and the fossil evidence was about 7 million years ago. That's our best guess for when we as human beings had a common ancestor with the chimpanzees. Now, you have that common ancestor. Some of that common ancestor's descendants became modern chimpanzees. And some of them, maybe they explored the right ecosystem where it was more advantageous to do so, started to walk on two legs. On two legs. And the most famous fossil of this is the Australopithecine fossil of Lucy that was discovered 3.2 million years. Oh, it was discovered more recently. It's 3.2 million years old. So the whole genus, and genus is kind of one level of categorization above species. The whole genus of Australopithecine, these were 4 to 2 million years ago. 4 to 2. And we never know. You could always find a fossil that's older than this, maybe newer than this. I read one account that says maybe 1 million years ago. But give or take, the Lucy fossil, which is the most well-established Australopithecine fossil, is about 3 million years old. And this is a reconstruction I have over here of Lucy. So this is probably what Lucy looked like. And once again, there were many Lucys. It wasn't just there was one Lucy and we're all descendant from Lucys. And it's actually not even clear that we are even descendant directly from Australopithecine. We might be a cousin species from, or a cousin genus, I should say. Genus is the category right above species. So if you fast forward a little bit more, you go to about 2.3 to 1.4 million years ago. 2.3 to 1.4 million years ago. We see fossils that they're standing upright. The brain size is bigger, because if you look at the Australopithecine fossils, they are standing upright, but their cranial capacity isn't that different than chimpanzees. You fast forward to 2.3 million to 1.4 million years ago, we start to see fossils where they're standing upright still, and the cranial capacity has grown, and you're starting to see primitive stone tools around the bone fossils. And so we believe that these are one of the first, and this is really just how we categorize it, but these are some of the first fossils that we categorize as belonging to the same genus as ours. And the genus is Homo. And Homo just means man. So it's the group right above species of man. And we call them similar to man because it looks like they're starting to make primitive stone tools. They stand upright like us, and they have larger cranial capacities than the Australopithecine fossils or modern chimpanzees. And once again, we never know we don't know if Homo habilis, which literally means, so the Homo part means man, habilis means handy, because he liked to, I guess, make tools or whatever else. We don't know if Homo habilis is a descendant of Lucy's species, of Australopithecus, or maybe a cousin species. Maybe they're both descendants from some common ancestor. We're not quite sure. Then you fast forward a little bit more. We're talking now about 1.8. So now we're talking about 1.8 to 1.3 million years ago. And we start seeing fossils where the cranial capacity larger than Homo habilis, getting closer in size to kind of what our notion is of kind of a modern person's cranial capacity, at least relative to body size. And this is Homo erectus. And once again, we don't know if Homo erectus is the descendant of Homo habilis. Maybe they have a common ancestor. Who knows? And it looks from the fossil evidence that there was, especially when you look at this range here, that there was some overlap where you had both Homo erectus and Homo habilis living on the same planet at the same time. Now you fast forward even more, And we think about 600,000 to 300,000. Once again, we're all of these are constantly being modified as we get better at finding new fossils or interpreting the fossils we have, or we look at DNA evidence or whatever. About 600,000 to 300,000 years ago, you have the Neanderthals appear. And Neanderthals are in the same genus as humans. So it's really Homo neanderthalensis. I always have trouble saying this. So this is still part of Homo. And a common misconception is that the Neanderthals are somehow a more primitive version of humans, that they're somehow cavemen and we're modern men. That's not the case. The belief is that Neanderthals are either a cousin species, we have a common ancestor, or that they're actually a subspecies of human beings. And there's some belief that they might have interbred with Homo sapiens, and maybe some or a good number of us have Neanderthal genes. And it's nothing to be ashamed of. It's just something, unfortunately, that Neanderthals just get a bad name because of I guess our popular culture. If anything, so this is a drawing of a Neanderthal brain. They actually had a fairly large cranial capacity, although scientists say they kind of make one reason or another why we think that they might have been more primitive than Homo sapien. But who knows? We don't know. We're constantly learning things every day. But of course, the whole point of this is to talk about how humans showed up on this planet. And the first really human fossils we find about 200,000 years ago. And this, remember, we're in the genus Homo. And now we finally found something that looks just like us, anatomically at least. We can't study its behavior and all the rest. And now we get to Homo sapiens. The Homo part, once again, means man. And the sapiens means thinking. So we can debate whether it's an appropriate title for our species, but it's thinking man. And so once again, the Neanderthals, they were either a cousin species for a lot of this time, especially once Homo sapiens showed up. And maybe Homo sapiens showed up before this. We just haven't found the fossils yet. They were maybe both inhabiting the same planet. Maybe there was some interbreeding. But the Neanderthals disappeared about 30,000 years ago. 30,000 years ago, these guys disappeared. Maybe some of them kind of got mixed in with the Homo sapiens, started to interbreed with them, or they might have just been killed off because they were fighting over the same ecosystems. And I've made a little sample here of Homo sapiens just in case. Well, I'm assuming most of you watching this video are one, but just in case, here's my little sample. We can debate how representative of a sample of our species this really is.